So 3D printer spools are actually a really horrible product because they can't really be recycled, they're way too heavy, and they're way too expensive actually for the spool manufacturers most of the time. So we went ahead and after having created several spools in the past, we decided we're just going to go ahead and fix that. So what are the problems with filament spools? Well, the main issue is that filament spools were never designed to really be disposable. They were designed to be reusable. Now, people inside of the 3D printing industry wouldn't say this. They're like, well, you can't reuse them. You got to ship them back and all the rest of them. But that's not the case. Most of these industrial filament spools were used for plastic welding. And in plastic welding, basically what would happen is the winding company would fill the spools with plastic and then just ship them down the road, not across the state or around the world, just down the road to the other factory that was using whatever was put on the spools, and then that factory would ship the spools back up the road in the back of a pickup truck. It wasn't that big of a deal because it was all used in a very close proximity manufacturing environment. This is why there are so many filament manufacturers in the Midwest. They're there supporting other industrial manufacturing. So these spools were made to be used over and over again over a really long period of time. They were meant to be industrial grade, reliable, consistent, without breaking or wearing out really at all. So they were very tough. But that doesn't work for 3D printing. Inside of 3D printing, the spools are meant to be disposable. Now, you could say, well, why not build a reusable spool? Why not use the master spool system or something like that? Well, the issue is the master spool system doesn't work either because the creation of the product for the master spool is a bad product. When you are giving the customer more effort to use your product in the form of buying special filament that has fewer options and then manually assembling it onto your spool at the end, you are causing a worse consumer experience than buying a spool, costs an extra $1, and then you throw the spool away. Customers are lazy, and that's not their fault. The product designer should create a product that the customer enjoys using and also makes their life easier, not harder. So the master spool is not a good option. And the even worst version of that is shipping spools back to the manufacturer because the economics of that just don't work. The cost to ship an empty spool is about $5 right now because of the cost of gas, the cost of labor, and the cost of shipping in general. So shipping spools around is not a very efficient way to do it if you are not filling a truckload with them. The other issue though, even with filling a truckload, if you're making thousands of spools, those spools do not pack very tight. They pack very badly, as a matter of fact, to where a pallet is not able to hold very many spools at all. It's able to hold several hundred, but it should be able to hold several thousand. But the spools can't be broken down or flattened at all because they're round cylinders that overlap a little bit, but not a lot. So spools right now just aren't intended to be used for consumer products. They're intended to be used in industrial products. So we decided to go ahead and design a new spool, a spool that addresses all of these. And when we started with that, we knew the spool would have to be disposable. That doesn't mean it has to be wasted. It just means that it has to be able to be thrown away and recycled easily for the customer. In order to do that, we basically have to use cardboard. But if you look at cardboard spools right now, they're not any better than plastic ones. They're over-engineered, super heavy, super expensive, and aren't really very easy to recycle because they're so heavy duty. Now that improves the user experience because the user feels like they're creating a green result from using cardboard, but the energy going into those cardboard spools is exceptional. And since they are so dense, they use way more raw material than traditional cardboard. So how could we make a spool with regular cardboard? Well, we had already done this. With the Slant Spool V2, we had used regular old cardboard for the flanges of the spool. But then we had a problem with the core. And while back in COVID times, the Slant Spool version 2 was a good option when there were no other options, it was too expensive to manufacture and the core took too long to print, so it wasn't really scalable into the millions of spools. We couldn't get a spool down to nickels and dimes in order to make it affordable at that level, which is what mass production 3D printing really needs and what mass production of spool filament really needs. So in order to make the spool more mass manufacturable than it was, we kept the cardboard flanges and we kept them octagonal so that they could be lined up along a shelf without rolling away. While this is an issue for some users who actually have the spool ride on the outer rim, most machines actually ride on the inner core, so it's not a big deal. But now we still get back to that core, that pesky core that was really tough to 3D print before. Okay, so we want to use a minimum amount of material on this. Well, in order to get a minimum amount of material and rapid print speed, you want to completely eliminate anything extraneous. So we don't want infill, and we don't even want the inner rim. The inner rim isn't necessary because we have those cardboard holes. We'll reinforce those a little bit, and we'll use some caps to make sure that the flanges are stuck onto the core well, but you don't need structure there. You just need structure on the outer side where the filament is being wrapped around. So for that, in order to create structure, we'll use a traditional structure. Use waves, use trusses, use whatever. So what we did was we designed a core where the outer edge is wavy. This gives it a lot of structure to where the layer lines are no longer brittle. They're perfectly within their spec for the amount of strain that the filament can put onto it. Using these waves allows you to create a lot of structure, while at the same time also creating a core that has some give to it. But that is made more rigid again when we glue or adhere the two outer flanges onto that inner core. While it is flexy, while it's loose, it becomes very rigid once the two sides are secured. But then we got to take that one step further. Okay, we have this 3D printed plastic part. That doesn't sound very recyclable. 3D printed parts don't biodegrade and very often don't even recycle. So here's what we did. While there is plastic there that can't necessarily be recycled, it is a minimal amount. It is just a few grams. And since this spool is no longer glued together and is no longer heavy plastic or heavy cardboard, all you have to do is step on it and it crushes flat. It doesn't take up a ton of room in your trash. The two flanges can be removed and then thrown into their own recycling, and then what remaining small amount of plastic that exists can easily be ground up and reused. Maybe if you're able to make filament yourself, you can run it through your own filament extrusion machine, but it's easy to grind. It's not giant chunks. So that is what we did with the slant spool. We did a few other little tricks on it too. Since it's a cardboard outer spool, you no longer have to have holes that create kinks, and since the inside is rippled, you no longer have to have a single finding hole, which is really nice for filament manufacturers. So that is the new slant spool. It is a way of addressing all of the problems with 3D printer spools and making it scalable. This spool will be going on sale for filament manufacturers here in the next couple of weeks. Reach out to us if you want to get a few. They are the same cost as traditional plastic filament spools, a whole lot easier to recycle, and they pack and ship way more densely than before. So we hope that this will be a better option for the filament manufacturers, a better option for the consumers, and a better option for the world as a whole. Because when you want to make a product, you need to design for what it's being used for. When you use legacy stuff, you get legacy problems. Have a great day, everybody.